The Diesel Performance Podcast contains explicit language.
Thank you for joining us again. This is Paul Wilson.
And I'm Nick Pregnitz.
And you're listening to the Diesel Performance Podcast. Man, we've had a great couple of weeks here. A lot of the UCC competitors coming on. Randy Reyes, Derek Rose, Zach Fuller, Levon Miller. It's been just such a blast. We really appreciate all of your guys' feedback. Please keep the messages coming. Of course, rate and review us on iTunes. That's a really big one for us. And if you haven't heard us talking about it, make sure you call over to Calibrated Power or Duramaxtuner so you can use your 10% coupon for any tuning purchase. That's Duramax tuning, LML switchable stuff, the 2.8 liters, tractor tuning. You can get 10% off. Call and work with any sales rep. Just let them know you listen to the podcast. You want to get that 10% off. Today, I am really excited. We have Nick in the studio. Danny's out of the office today. So we brought in another big hitter. We thought, why not have Gale Banks back on to fill Danny's shoes?
Hey, we'll trade Gail for Danny any day.
How's it going today, Gail?
It's going good.
Glad to have you.
Thank you.
Excellent. Yeah, we are so glad to have you back on. Last time we talked a ton about the L5P. We talked about dynoing and a lot of other stuff. Today we want to dive into the L5P top end, and we have a few other topics. Nick, I think you were going to kick us off with asking Gail a little bit about Duramax engine builds.
I mean, we're the Duramax crew, right? So let's get on with it. We had an awesome episode last time we had Gail on. We really went through the L5P bottom end, we have a solid part of this episode devoted to the top end of the L5P, including the oiling system up through the pistons to the heads and whatever else new they got going on up top there that Gail's going to tell us about. But first, I want to jump back into a little bit of Banks technology stuff, and Gail has told us several times about his engine building history, about what Banks is up to, and I think we owe it to our listeners to give them a wider picture of what Banks offers engine-wise, right? So it's not just the Oshkosh platform. Banks is also building performance Duramax engines for ? Fill us in, Gail.
Yeah, just about anything you'd want. Bonneville, drag racing, we're doing one for a pickup truck right now, which is an earlier Chevy pickup truck, which is a super turbo. In other words, a blower sticking through the hood with two turbos, one on each side towards the aft end, and it's using our marine intake manifold with a liquid-coupled intercooler core inside the manifold, and it's a ram tube type manifold, so it's a tuned intake manifold.
Okay.
That engine's kind of interesting because we're using our billet crank, Carrillo rods, and some prototype steel pistons in that one.
In the Duramax builds, did I catch that correctly?
I have two of them being built right now. Basically, a while back, Molly, or Mala, however you want to say it. I say Molly.
That makes two of us.
Yeah.
Three. There you go.
Yeah, well, I tell you, you go to Germany, and they say it both ways.
Yeah.
Depends on what part of Germany. So if it's okay to say Molly in Germany, I'll say it here.
There you go.
So those cats, they did the pistons for us back in the early 2000s for the Cummins 5.9 marine engine that I did.
Now, just to stop you real quick, Gail, are these the Molly, the monotherm pistons, the two-piece with the steel top and the aluminum skirt?
No, it's a one-piece steel piston.
It's a one-piece steel piston, okay.
Yeah.
Sorry.
Some of the medium and heavy-duty engines do use the monotherm.
Yeah, our ISL has that two-piece style.
Yeah. And it's a hell of a good piston.
Yeah.
This is a one-piece and as light as I can make them. So they built 4 sets using the forging for the Cummins. It had adequate material to build a bigger diameter piston out of it for the Duramax.
Okay.
So they built 4 sets, our valve pockets, our bowl type of thing.
Yep.
That we've been doing in the Molly aluminum piston, and 2 sets were sold off to 2 other companies to screw with, and then I've had 2 sets sitting around here for a while, but I haven't been able to get to the program.
Mm-hmm.
Now I've built 2 engines. They're customer engines with billet cranks and Carrillos and
Yeah, the whole 9
these
yards.
steel pistons.
These things are big. I mean, they're heavy pistons, right? I mean, isn't that the...
Actually, the pin is much shorter, so and the piston's heavier.
But you're
But
saving
what we've
on the
done
pin?
is the skirt. Geez, I wish this was a like YouTube thing. The skirt isn't solid. In other words, there's a gap between the skirt and the ring belt.
Okay, I see what you're saying.
Literally, you can see through the piston. It's like 3/4 of an inch of daylight where there's no steel.
Okay.
Where it was aluminum, there'd be aluminum.
So right underneath the oil control ring, there's a gap, and then you get to the skirt, which is lower.
Yes.
Okay.
So that
Copy.
eliminates weight. The shorter pin eliminates weight. And if we did a forging, proper forging, see the inside diameter of the piston is accommodates the smaller bore Cummins. But we're doing a bigger bore with a small inside, so the wall of the piston is quite thick. We could get some. If we do a production version, it'll be
You
lighter.
could cut it even more. Yeah, I see what you're saying.
Gotcha.
So we got a lot of heavy metal in the crank to counteract it. But we built one as a super. They're both going to be super turbos. One is a marine prototype that I'm doing on my own dime for the Navy. In other words, they're running the Cummins designs that we did, 15 years ago.
Mm-hmm.
And they are quite durable, but they're quite heavy, and they want a lighter engine.
Okay.
So
So you're banking on the fact that they like this one so much they contract with you for another?
yeah, I'm taking a chance.
Yeah.
But the other side of it is, I've got quite a following worldwide in marine. You know, we did twin turbo gasoline big block Chevys and sold them worldwide for 30 years.
Yeah.
And I kind of wound that down when we started pioneering the diesel aftermarket back in 80, 81. And kind of that took off, as you guys are part of it today.
Mm-hmm.
And so we have thousands of friends who are also in the business you and I are in. So, you know, we used to be alone in San Gabriel, California. So the point being that we want to make that steel piston production. I think that's the next step in how far we can go with the diesel engine. Yeah, you can run your 20-second blasts, and it's not going to change a thing. I don't think in truck pulling, it might. It might.
Yeah, no, I'm with you though. I mean,
probably
the marine markets the steel piston's what you have to have the high horsepower marine market for the diesel, right? I mean, that's what you're getting at.
Pretty much, yeah, pretty much, because we really run them. You know, you got to look. It's called duty cycle.
Yeah.
On the street, you're rarely at wide open throttle.
Right.
In a truck pull, you're at wide open throttle nominally 20 seconds.
Yeah.
At Bonneville, you're at wide open throttle for 90 seconds, maybe 2 minutes, depending on how fast you are.
Mm-hmm.
And then you turn around and do that again. You got to have gallery-cooled aluminum pistons at Bonneville. If you get away with what you know, most really serious truck pull pistons have no oil gallery in the piston crown. You can't do it with a forged piston.
And just so we're clear for our listeners, when you say gallery cooling, you mean that there's physically a passage within the piston that is internally cooling it.
Yeah, and there's an oil jet on the engine. Early Cummins don't have this, and then about the time they went to common rail, that late 90s, I think, early 2000s, they went to cooling nozzle,
right,
where they spray oil up into a hole in the bottom of the piston crown.
Right, instead of just
There's
spraying the bottom of the piston.
Yeah, instead of just spraying the bottom of the piston, they spray inside the piston. It's a circular gallery that has a exit hole on the opposite side of the piston. So on the steel pistons, we did that as well, and we put 2.8 gallons per minute per piston into those pistons.
Okay.
So you think that's a hell of a lot of oil to flow through a piston crown in 1 minute.
Yeah,
for sure.
And that's with steel pistons to keep them cool enough. The new Duramax L5P is around a gallon a minute. In fact, I had my oil distribution analysis around here somewhere.
Now, is that a peak load? Is that a peak RPM, or what? When you flow these things?
Yeah, that's it.
Stats?
Yeah, we normally measure all that stuff at 3,150 RPM.
Okay.
In fact, if you hear an engine running in the background at full power right now, it's an L5P in dyno room number 1. Not a production engine, but we're doing a whole bunch of experimental oil system upgrades for competition on the L5P.
Okay.
I can't find my oil system analysis, but it's a little over 1 gallon per minute. So you got 8 gallons, 9 gallons, 10 gallons a minute, just being injected into the bottom of the piston.
And if I put you on the spot and ask you what the previous model year LML piston cooling,
Yeah, around 7/10 to 8/10 of a gallon per minute.
Okay, so a 30% increase, roughly?
Yeah, 25, 30.
Okay.
The nozzles are much bigger in the L5P than they were in the previous engines.
I'm kind of surprised to hear that they made that modification. I don't hear a lot about piston failures or any sort of heat issues with the LML. I'm surprised that they went up for the L5P. I wonder if that was just to compensate the extra power.
The LML is 397 horsepower. The L5P is 445. Right there, I'd want more piston cooling.
Yeah,
it's a
but there's overhead.
Deal.
The L5P has overhead. In other words, the structure of the engines supports a 20% increase in peak cylinder pressure. You can go 150 bar with the earlier engines and 180 bar with the L5P. The cylinder head bolts, there's 2 additional small cylinder head bolts. The main bolts are stronger. The wrenching pressure is higher. Head gaskets are upgraded as well, similar but upgraded. But, a bar of pressure is, 1 barometer or 14.7 pounds.
Right.
So they've gone up. It'll support 20% higher firing pressure. So just rule of thumb, that would take us from 400 or 397 to 480, and they're at 445.
So unofficially, Gale Banks says GM's got 480 potential on this motor?
Yeah, call it 500.
That's where I would round it. And hey, guys, we're going to get right back to more L5P talk right after a quick commercial break.
Hi, I'm Phil Grandinetti, Service Manager at Calibrated Power Solutions. As you probably know, we install high-performance equipment for your diesel truck. Twin turbo kits, dual fueler kits, injectors, our stealth turbos, our DT750 and DT1000 transmissions. But what you may not know is that our techs can also diagnose and repair most of the systems on your truck, including electrical, starting and charging, AC, brakes, ABS, steering, and suspension. So please call us if you're having issues with any of the systems on your truck. We will help you through the process of diagnosing and repairing the problem. You can reach us at 815-568-7920. That's 815-568-7920.
And we're back with Gale Banks. Really excited, digging into more L5P talk. This should be really good for us here. Nick, I think we were just starting to transition here and to talk a little bit more about L5P stuff.
Yeah, I like what you're saying there with the higher cylinder pressure, Gale. And I want to take our discussion about the steel pistons and our oil cooling and the piston upgrades on the L5P. And GM has talked about this laser remelting on the bowl of the L5P. Not a process I'm familiar with. Seems interesting. Anything to it's no secret in the Duramax world that piston failure is usually right on the lip, right in that peninsula area on the recumbent bowl. Looks like GM's on course to correct that. Any thoughts?
Yeah, even the radius, they screwed with the radius of that as well. The more generous the radius, the less fragile it is. In other words, it doesn't come to as fine a point, so to speak.
Yep.
But there's a balance between emissions and that radius.
Okay.
So they wanted the proper radius for their emissions numbers, and they still wanted to make good power. The injected fuel impinges on that. And when you really, really, really inject a lot of fuel and go real rich on your air-fuel ratio, it gets quite hot in there, and it'll burn back the piston right at that lip, so to speak.
Yeah, we've seen erosion right there on that lip on engines.
Yeah, and you know where the openings are in the injector nozzle.
Yeah, exactly. When you tear the head off, you can see them outlined.
Right. So and sometimes that's where the pistons burn back. So the laser remelt. See, these pistons, to have the cooling gallery in them, they have to be castings.
Right.
So they also looked at steel pistons. I don't know if that's published, but
it is now.
And they made this decision to stay with aluminum, but do the laser remelt. And what it does is it just reconfigures the molecular structure or the grain structure in the aluminum in the area where it's been remelted, and as a consequence, it'll take higher temperature in that remelt area. So they remelt that, and then they machine it.
Okay.
So it all looks pretty uniform when it's done. It's hard to tell where it starts or ends.
Okay.
But it definitely makes a piston more durable. The other thing they've done on the piston to make it more durable is they've increased the diameter of the wrist pin. So, and the piston, to accommodate that, they had to make the piston longer,
right?
The bigger wrist pin. So they raised the deck surface on the engine, that being the distance from the center line of the crank to where you bolt the head on
okay.
to the deck.
So they didn't have to
they
shorten the rod up.
They raised that 4.3 millimeters.
Okay.
And the pistons are about 4.3 millimeters taller.
Okay.
That accommodates the bigger wrist pin, and the ring belt can still be the width you want it. And you can still have the skirt stability.
Sure, without changing the rod angle and messing with all that side loading stuff.
Yeah. Now, I don't know that the pin center line is exactly where it was, but the rod angle is so close. That's a function of the length of the rod.
Right.
But it's just damn near identical to the earlier engines.
Okay.
The tall deck is something I like because it allows me to do my crankshaft with a full radius counterweight.
Why is that a benefit?
Well, I like to zero balance the engines. In other words, if I'm going to turn them in the marine engines where we turn them in the 44 to 46, 4,800 RPM range, maximum, the counterweights, we still put some internal weight in them and lighten up the outside counterweights in the flywheel and the front damper. What happens with a heavy counterweight at high RPM, especially on the nose of the crank, is it bends the crankshaft while you're running.
Okay.
Here, I'll give you another little piece of information that's not common knowledge. Take a counterweighted. There's different counterweights, you know, LLY, LBZ, LMM, LML. The counterweights vary somewhat, but using the average counterweight at 6,000 RPM, you have a 7,200-pound bending load on the nose of the crank. Trying to bend the crankshaft, it's like a teeter-totter.
Sure.
It's like you're pushing down on the crankshaft, and the pivot point is the front main, and you wipe out the second main. It'll bend the crankshaft enough to do that. I've done it with billet cranks.
You know, Gail,
And
I was actually just going to say here, I hate to interrupt you, but we've actually had this discussion with some local engine builders about internally balancing and externally balancing the crank. So you're saying at 6,000 RPM, you're seeing clearly there's a benefit, right, to go one way as opposed to the other. Do you find the same wear at lower RPMs?
No, because you can calculate the bending load versus RPM with the full counterweight. I'd say you're pretty safe up to 3,800, 4,000 RPM.
Okay.
At that point, I start taking out counterweight on the flywheel and on the. I own the oldest balancing shop in the United States. It's called Automotive Balancing Service, and it opened in the 50s. So we're pretty good at balancing. I folded that business into Banks Power probably 15 years ago. So we don't do business as Automotive Balancing Service anymore. But we sure as hell know what we're doing. And, you know, no performance engine that turns. It depends on the amount of counterweight, but in a Duramax, 4,000 is where I'd call it quits. If I were going to run the engine there for a while.
Sure. Marine
Now,
application.
Yeah.
Yeah, there's a lot of guys who break the crankshaft in the number 1 throw, and sometimes in the number 4 throw, but I haven't seen them break too commonly anywhere else on the Duramax. And the reasons are pretty profound. I mean, remember I told you about the billet crank that I bent at 6,300 RPM. That was with counterweight, and I didn't break anything. Billet cranks are pretty tough that way, but I did bend the crank. I mean, I bent the crank almost a full 1,000.
Wow.
Anyhow, and wiped out the second main and kind of damaged the front main.
So
didn't destroy the engine. Just hurt the crank.
Did it bend at that first throw? Is that?
Yeah, it bent through there.
Okay.
Yeah. Now, if it was a standard crank, it probably would have broken there.
Yep.
My point is, if you got a counterweight and a standard crank and you turn it hard enough, you'll either bend or break the crankshaft. Now, the second reason guys break crankshafts is not the firing order. Okay? It's not the firing order. You guys change the firing order on Duramaxes as if it's some form of magic, and all they do, the Duramax, if you look at, you got to ignore the cylinder numbering and just look at the cylinder location as they fire. In other words, a small block Chevy fires like a Duramax, and a big an LS Chevy fires like the alternate firing order that guys put into Duramaxes.
Mm-hmm.
They act like they've created frickin' magic when all they've done is move the firing sequence of the engine to the same as a gasoline LS small block Chevy. That's it. So I'm writing an article on crankshafts and firing orders and all of this stuff and crank breakage for diesel power magazine.
Are you saying that there's no benefit to an alternate firing order cam then?
I'm not saying there's no benefit. I'm saying it isn't the reason you break or don't break a crankshaft.
Okay.
You'd have to be really running a long time to find the difference there. Let me qualify the statement. In my article, I'll explain firing sequence, but let me just tell you this. If you know how a Harley-Davidson V-twin fires,
Mm-hmm.
they fire. They don't fire evenly. If you look at firing on a V8 engine, there are 3 bays that fire 90 degrees apart, and 1 bay that fires, what the hell is it, 270 degrees apart. And all you're doing by changing the firing order is you're moving that odd bay from the front to another location. So check that. You're moving the odd bay to the front. It'll all become clear in my article because I'm doing it with some illustrations. But the other reason guys break the number 2, maybe the number 1 reason, other than counterweight, I'd put counterweight number 2 because a lot of the guys are breaking cranks and they're internally balanced. The second reason it would be counterweight. The first reason is vibration damper. Aftermarket vibration dampers or OEM vibration dampers in a performance application. First of all, an OEM vibration damper is tuned to a certain, if you will, vibration point in the RPM range, which is the worst point.
Okay.
So what we do is we measure the crank position in the front and in the rear while we're running on the engine dynamometer so we can measure crank twist. And I usually don't want the twist in the crankshaft to be more than a plus or minus a quarter of a degree of crank angle. You with me?
Yep.
Okay, so what do I do? Well, we've been designing our own dampers, and the Horschel brothers have been making them for us for a long time. They're viscous dampers. And we either have a steel or a bronze inertial ring inside of them, and we can tune them. Secondly, they tune for very broad band. They're with a rubber coupled vibration damper, whether it's got a bunch of O-rings and made by an aftermarket company, or it's an OEM damper with a solid sheet of rubber. They are very specific to a given speed and load of the engine. If the O-rings are melting in the damper, and that's what happens a lot of times with these aftermarket O-ring dampers, you're not going to have a very good crankshaft life.
Forget about
if
it, right?
The elastomer is breaking down. In any endurance engine, we do not run rubber coupled dampers. They just don't live, and they're very specific to 1 RPM. So the minute you change the pistons or the rods, or you turn the engine a higher RPM, or you make more power, we do a thing called a mass elastic calculation. We look at the weight of the pistons, the rods, the pins, the bearings, the rings, the RPM, the diameter of the journals on the crankshaft, the mass of the torque converter. There's all kinds of stuff that goes into our mathematic calculation. And then we build dampers, prototypes, that should solve that situation. And we'll build one right on target, and then we'll build 7 different dampers. 3 each side of the target and 1 right on target. Then we go on the engine dyno with this specific crank and everything else that we're running, and we measure the twist in the crankshaft. at various orders, vibrational orders. First order is the speed of the engine, and then you go from there. Firing order, firing sequence. You're firing 4 cylinders per rev, so you've got that vibration order. And basically, what I'm saying is, we know what the crank is doing, and we tune the dampers to prevent the crank breaking. The crank's like a big, long torsion bar. It's anchored with a torque converter on one end and the flywheel mass. And then in the front end, it's super flexible. So the damper helps damp that flexing on the front end. That's basically how you keep a crank alive. You have a proper vibration damper. Guys who run blown engines with just a crank hub, a blower drive hub, and no damper. I did that at Bonneville before I knew better in a small block Chevy and broke a crankshaft. In another one, it shook so bad that the oil pump broke off the engine and killed the engine. So real quick, I learned about crankshafts and dampers, 40 years ago.
School of Hard Knocks.
How do they look in the L5P? Do we have some pretty solid groundwork from the OEM on that platform?
Yeah, what's kind of interesting? We ran our mass elastic and our damper design, maybe a year ago, and the crank is a lot stiffer because the rod journals are so much bigger in diameter, and the crank stroke is the same.
Really?
And the rod journal to main journal overlap of those two diameters is increased over the earlier cranks. So the crankshaft is a bulletproof mother. And they've done coined or rolled radiuses instead of full radiuses. We talked about this, I think, the last time we talked.
Yeah, for sure.
So the crank is a lot stronger, but the entire calculation came up very close. Oddly, we're making more power, so we're putting more twist into the crank, so our damper is very close in design to our earlier one. It's got a different counterweight because we build one that can replace the stock damper, as well as we're building them for with no counterweight in it. We're coming out with a whole line of performance Duramax dampers.
Okay.
And
so, what are you guys using instead of the O-ring? Like, what? I'm trying to get my head around. Is there any elastomer? Is there any? Right, like how? Can you fill me in on that?
Yeah, the inertial ring, which would be the outer part on a conventional damper with a rubber. There's no rubber. You have a ring inside of a housing with a silicon fluid filling the housing between the ring and the housing.
Okay.
So the mass of the ring, the gap between the housing and the ring, and the viscosity of the silicon are all tuning points. So they're very tunable.
Sure.
Not in the field. They're very tunable in development.
Right. Well, you wouldn't want somebody changing oil in their damper.
No. In fact, there's a fill and a vent port on the face of the damper that gets welded closed.
Come on, man. I can do it. I'm fine. I'm good.
Yeah. Here, let me drill this out. I'm going to put a little 5W40 in here.
Right, loosen it up a little bit.
So, yeah.
Somebody would run two.
Anyhow, a lot of the bigger diesel companies use viscous dampers. It's very common there. They just cost more. That's the problem.
Yeah. So we get this crankshaft failure figured out, and then we get the steel piston, and we get the remelted bowl figured out. I mean, what is what is next, right?
The bottom line is we're also putting a bolt pattern on the front of the damper so you can drive stuff.
Okay.
like a supercharger or a lot of guys run water,
Water pump.
ice water
Yeah.
coupled or whatever. You need a big pump for your intercooler.
Yeah.
Most 12-volt pumps won't handle it. So, you want to be moving 80 to 100 gallons a minute through your liquid-coupled intercooler. And if you're moving 30 or 40, you're not getting the full effect.
Sure.
So, anyhow, we're doing a pump drive to mount on the front of a Duramax to run the big intercooler systems. A new double fuel injection pump set up, and there's a bunch of stuff we're doing.
Okay.
We're doing the same thing for the Cummins. We've just done a new monster ram for the 6.7. You know how those things, if you guys tune a lot of 6.7s, I'm sure.
For sure. Yep.
And the fuel injection line cuts right through the casting down where you bolt it to the cylinder head, where the heaters are. And we went to the guys that make the lines for Cummins, and we designed a new injector line, so it does not interfere with our casting. And then we were able to make the casting flow beautifully with no compromise whatsoever into the intake.
Yeah, open up that top end
So,
there.
yeah, so we would call it a monster ram.
Nice.
I'll send you a picture of it. It's bitchin' looking.
We'll make
Just
sure we get that
ridiculous.
link up in our show notes, too, for that, so
Yeah.
our listeners can click on it.
Yeah, people love that
Yeah.
stuff. They eat it up.
In fact, I'm just sending one to some guy that runs a dual pump Cummins to make sure that I haven't. It's so darn big in cross section and flows so well. It's got a 4-inch inlet on it instead of a 3.5.
Okay. Nice.
And it's pure race. It doesn't accommodate throttle. So I do a 3.5 and a 4, both.
Okay.
Anyhow, I'll send you a picture of it. But back to the Duramax. I'm drifting around here.
That's all right.
We were going to start to talk about the upper end on the Duramax. I talked about the head bolting and sealing and the more rugged design. The block itself is about compared directly to the earlier blocks. I think it's about 9 pounds heavier. But the earlier blocks have bosses on the lower front for the old medium truck mounts.
Okay.
The top kick and Kodiak.
Yeah, the chin mount.
Well, those are gone on the L5P. So I'd say there's 12 more pounds of structural high-strength cast iron in an L5P block than there is in an LML or earlier. That's meaningful.
Yeah.
And hopefully they've got that up in the deck area. I'm sure they do because of the wrenching. If you're going to have more wrenching pressure, more head squeeze pressure on the head gaskets, you got to support the top of the deck can't deflect or distort when you torque down.
Right. So
they've got
the thickness on the
think
deck
that-
is what we're looking for.
Yeah, I'm pretty sure the deck's going to be stronger. I haven't sawed up a block yet, so I can't tell you, head bang. As far as airflow in the L5P heads versus the earlier ones, and swirl, they've improved intake, exhaust, and swirl in the engine. Probably the most profound increase is the exhaust port. One of the things about diesel, if I'm really going to get serious with a diesel, I want a lot of exhaust port. Traditionally, the intake ports flow more than the exhaust ports. I mean, that's just how the world works, how everybody does them. I always like to try to get here's the deal. You push the air in, so to speak, boost pressure pushes air density through the intake manifold around the valve and into the cylinder. The only thing that pushes the exhaust out is the piston. In other words, you take a lot of energy or power out of the crankshaft to push the piston up the bore on the exhaust stroke. So I don't want to compromise that too much. So I try to get the exhaust port to flow very close to what the intake port flows.
Yeah, I mean, we're already fighting against the turbocharger and drive pressure in the manifolds. Why fight around the exhaust valve on top of that?
Yeah, all of the above. On a lot of engines that I've done that are pure race at very high output, the exhaust and intake valves are the same size. And the exhaust port probably flows 90% of what the intake port flows.
That's a bold statement, Gail.
So in the case of and I'm looking right now at the flow on the ports, if you look at 600,000 lift, which is not where the engines are,
Yeah.
The intake port on the stock head is flowing. Let me go to the table here, and I'll tell you. The intake port is flowing 206 CFM.
This is combined?
And this is done on a SF, 1050 Superflow, the big Superflow bench.
Okay. This is our combined. This is
So we're
both
getting
ports on the intake, right? This is combined.
How's that?
This is combined intake port flow.
Yeah, this is, yeah.
Okay.
Yeah. So 206 on the intake, on the L5P, and 186 on the earlier heads. LML, LMM,
Okay.
they're pretty close to the same. Let me see. Okay, hang on. We're talking, let me get this straight. Hang on, guys.
No problem.
It's 187 intake flow on the earlier.
Okay, so that's
Gotcha.
a 9% increase on intake flow.
Okay. Now, you go to the exhaust side, the exhaust flows 186 at 600 thou on the L5P and 144 on the earliers.
Wow. That's a big
Yeah,
jump.
that's what I said.
That's a big jump.
Valve size is still 31 millimeters on the exhaust and 33 on the intake.
So to put that in perspective for the listeners, that's a 9% flow increase on the intake side and a 30% flow increase on the exhaust side.
I mean, that just completely changes
Remember,
the ratio too, right?
Yeah, I'm comparing at 600,000 lift, and
Yeah, so the
in
valve's
reality,
out of the way.
the stock engine doesn't lift that much.
Right.
So it's more, I would say closer to 400,000 if you want to talk.
But it'd be reasonable to assume that those proportions transfer at 400,000s.
Yeah, it's pretty good. I mean, the intake is, it's still. I'm looking at it graphically now. The intake continues to rise all the way to 600,000s, and so does the exhaust. So if they wanted to give the thing more lift down the road, the head would accommodate you with more flow.
Right, so it's cam limited.
I mean, yeah, you'll get to a point where if you take the valve out of the port, it still flows the same.
Right.
You know, at higher lift,
Yeah.
they'll flatten out, they'll plateau. Now, the part about the swirl really has to do with the use of fuel and the minimizing smoke and maximizing power, essentially. And at the same time, minimizing particulates and emissions and what have you. The swirl is grossly better from 200 thousandths up to 400 thousandths with the L5P head. It just kicks ass on the earlier cylinder head.
How are you measuring that? I mean, what? Just to put that, like, visualize that for us here,
Okay.
so people listening.
I'll give you numbers. Let me look here at, say, I'll go to 250 thousandths. The swirl RPM in the earlier head at 250 thousandths intake valve rise is 1,200 RPM. In the LMM LGL. Well, they didn't make the LGL. The LML. So 1,200 RPM versus 3,000 RPM.
Wow.
That is the rotation of the air in the cylinder.
Yeah.
Hard to believe, huh?
Yeah, that is a wild difference.
How do you even...
Now, let me tell you why that is so good. And most guys who port cylinder heads absolutely destroy the swirl. They just go for the flow numbers. Swirl is good because when you inject diesel fuel into cylinder, you inject it right at the center of the bore towards the outside of the bore. As the diesel droplets of fuel move through the air, they're burning. It's like they don't explode. They're not like gasoline. Diesel burns from the outside in until you've consumed it completely. If the fuel droplet runs out of oxygen, by that it can do that two ways. It either slows down because it doesn't have enough momentum, or that's the reason we've gone to higher injection pressures is to get smaller particles but still maintain momentum. So they keep moving through the air in the cylinder and burning like you're peeling an onion. That's the closest
in a spiral motion.
I could give.
I'm with you.
You're burning layers of molecules off as it moves through the air.
Sure.
If it stops and uses up the local oxygen, then
particulate.
Then you've made a little tiny briquette. I think if you got enough of these, you could make a hamburger. Put them in your barbecue and make a hamburger.
There you go.
So you've got this fuel particle that's been heated in the absence of oxygen. That's how you make charcoal. And that's what's going out the pipe. That's fuel energy you never used. So to keep the fuel and air mixing in the swirl RPM, you have a straight plume of fuel and you have rotating air. Secondly, as the air rotates, the density centrifuges out towards the cylinder wall. So you're injecting into the density, into denser air with more oxygen in it due to the rotational speed. It's like a ride that they used to have at the Pike down at Long Beach here, where you got in this big cylinder,
Gravitron.
and it started rotating, and your back was against the wall, and then the floor dropped 10 feet.
Yeah, and then half
and you're
half
just
of them
looking
puked
at
on
you're
you.
looking at the floor 10 feet below your feet, but you're stuck to the wall.
The whole place smells
That's what
like a bar
happens with
bathroom.
the air, and you're getting it now. So the whole deal here is swirl is a good thing.
Right.
It's part of making power, and these guys are so jonesed over the flow number that they've screwed up the cylinder head, and you're rolling coal and thinking you're cool, and you've lost 50 or 100 or 200 horsepower. It's not cool.
Yeah.
Horsepower is cool. Smoke is not cool. So
Amen.
I'm just saying. So these guys at GM did a number on this cylinder head. It's really good.
So they are.
And I haven't told you the best part. The exhaust port flows better too. I'm loving that. That's going to give you more horsepower as well, especially if you jack it up. We haven't even put big valves in this thing yet, and we got an improvement. The point is, what happens when we get in and start doing some experimental ports and ultimately CNC some of these things.
I hope you don't
It's gonna
screw the
be
swirl
pretty-
up.
That's the deal. I'm not going to squirrel the squirrel up. I'm not going to screw the swirl up, and it's going to be. It's hard to maintain it. You've got to. There's a lot of handwork developing a port. On and off the flow bench. It's quite a chore.
Yeah.
But one of my Cosworth guys is really good cylinder head development guy. So and we've done the swirl thing on the current engine.
Sounds like being able to measure it and being able to validate it. I mean, that's, you're ahead of the game right there.
Yeah.
Well, we measure it two ways. We also measure what I call swirl torque. That's the actual force of the swirling air.
Okay.
And that's measured with a different device. But I identify more with the swirl RPM. That's the measurement I like to work with.
So this has a lot to do with the way that the port is shaped and how it interfaces with the chamber, right? I mean, that's the swirl's all about, is the radius on the port or the curve of the port.
Yeah, and generally you've got what I call a mass flow port and a swirl port. One of them, if you study how the ports come into the
chamber,
the combustion chamber, or into the cylinder in this case, combustion chambers in the piston. One of them is kind of tangential to the OD of the bore, so it's really giving you velocity, and the other one is more towards the center of the bore. So that's the mass flow port.
Right.
One of the things I've done with my marine intake manifolds with the individual runners is set it up to put a butterfly in the mass flow port to really kick the swirl in the ass right up at lower RPM and lower valve lift.
Okay.
And then open the mass flow port. That's something we did, 12 years ago when we first did the manifold design. But we've never put the butterflies in. But it was kind of cool to see that the little VM Motori V6 does exactly that. It does exactly that. It validates what we're wanting to do and never did.
Yes, they have a dynamic change on swirl versus mass flow, whatever.
Yeah, they have butterflies in the mass flow ports.
Okay.
That open up once you get going. So here's the part I wanted to get to. If you look at all the earlier heads, the ports come right up to the gasket surface, and then you have an intake clamshell or manifold.
Right.
That is the standard piece that comes from GM. If you're hot rodding your Duramax, and that is still there, I mean, there's aftermarket versions of them too, but most guys are using stock head, stock intake manifold, or a stock head that's been ported in the stock intake.
Very rarely do we not use clamshells or not see clamshells.
That's it. Now the point is, the cross section of the clamshell is all the flow area you have to the end ports on both ends.
Yep.
From roughly, the air enters roughly in the center on the earlier engines. On the LML, the air enters in the front and near the front. But the clamshell, I haven't measured it, but visually it has greater cross section. But so does the head. In other words, the ports don't come up to the gasket surface. There's all this additional, if you will, feed area to all the ports towards the back of the cylinder head.
Okay, so they're recessing the head.
Now,
gotcha.
So what I told the guys in the cylinder head department was, how about we flow these heads and compare them with the manifold clamshells on them? That's going to be where I think the L5P is really going to blow the earlier ones away.
Yeah.
So I'll have that difference probably in the next week or two. We're running so much dyno work and oil pan development right now. It's pretty wild.
Well, that's a clever design. I mean, space is at a premium in the L5P. Space there's a lot going on top of that engine, and to be able to add plenum volume by milling the head down on the intake side.
Well, here at Banks, we are just airflow nuts. We're all about the density, all about the airflow. That's the key to everything. That and swirl. That's how we do it. But the I think the thing here is we're also becoming damn expert at crankcase air oil dynamics right now. We're doing a new upper and lower oil pan. The upper oil pan is aluminum and has a kind of a tray in it, and the lower oil pan is steel. For motorsports and for marine and for military, we're doing a commercial off-the-shelf upper and lower oil pan. And if you're doing twin turbos or whatever, it's got an oil drain back port on both sides.
Nice.
So
you do parallels if you want. Yeah.
You can do turbos on either side of the engine, and you got a place to drain the oil that's real convenient.
Yeah.
That's awesome.
And also we're doing the tray in the upper oil pan casting more like I would do on a racing engine, semi-dry sump technology on a wet sump. This is something that isn't finalized, but what we do is we run the engine on the dyno, and we have a sight glass like an old style coffee maker to see how much coffee's left in the glass.
Okay.
Yeah. One that holds like 100 cups of coffee.
Yep.
You've seen them.
Yeah.
We put those things on the sides of the oil pans so we can measure how much oil is in the pan when we're at full song,
Right, yep.
Also, we're measuring how the oil level in the rocker covers.
Okay.
And how well the oil drains back from the rocker covers through the 4 drain back ports in the block on each side. And the L5P has a breather at the left front of the engine that is really scientific, really sexy. It uses boost air. First, it centrifuges the oil-air mixture, and then what drops out of that little centrifuge section goes into a little sump in the breather, and boost air is used to blow the oil back into the rocker cover through a little jet. You ever see a deal where you use a thing you put on your garden hose and you can pump out your basement with that? Have you ever seen one of those?
Yeah, like a Venturi kind of thing almost, but...
Yeah.
Okay.
Yeah. So this is that kind of deal, only it uses air instead of liquid, and it sends the vapor, what you've collected out of the vapor, straight back in. So the air that goes, the blow-by that goes into the compressor inlet is free of oil.
Yeah, and that'll make
virtually
sense
dry.
Guys who have owned Duramaxes in previous years, you look at intercooler tubes around clamps and hose discharges. 200,000 miles on a truck, and there's, you know what I'm talking about. There's oil coming out of every single intercooler pipe connection.
Yeah.
So you won't have that on the
bottom
L5P.
line is, when you oil down the intercooler, inside the intercooler, it doesn't intercooler. It's not as effective. It damps out the heat transfer capability.
Yep.
You don't want oil in an intercooler.
Right.
So this is going to be the most immaculate setup you've ever seen. But if you're going to drive the power way up, I'm afraid you're going to overwhelm it.
Okay.
And if you overwhelm it, there could be some consequences. And this is something we're working on very strongly right now, because if you overwhelm it, then you bring oil, the oil. How should I say this? You get to a point where you might ship a little oil into the compressor.
Okay.
And that's what we're determining right now. We're running all different kinds of speeds and loads. We're trying to get more oil out of the valve covers and down into the sump where it belongs.
Mm-hmm.
This isn't a problem on a stock truck at all. This isn't a concern on a stock truck, period.
Right. This is not a 445
My
horsepower
concern
problem.
is how much blow-by can I go volume can this thing tolerate?
Yeah.
Right now we're measuring our blow-by rates are maximum of 5 CFM is our blow-by volume. And if you put in custom pistons with looser skirt to wall and, blow by more by the rings, let's say, perhaps,
Yeah.
you're going to overwhelm the capacity of the breather.
So
What we're working on here at Banks is a better, if it's necessary, cure for the breather on a hot rodded engine.
So you're going through the hassle of doing this upper and lower oil pan and re-engineering the wet sump system. Is this the type of system where guys maybe put this on a Chevelle or a Nova or a car with a different front cross member? I mean, you got to see the crate market.
That's what this is. This is a rear sump conventional looking oil pan.
Okay.
The pan is cast aluminum. The lower and upper are both cast aluminum. We increase the capacity to nominally 12 quarts. I think stock is 10. And I'm setting it up to separate the oil and air. The way the tray is shaped, it's like a kick-out oil pan on a drag race engine.
Okay. Yep.
We're using that type of technology,
Yep.
but a much more refined design. There's what I call the up windage side of the engine and the down windage side of the engine.
Yep.
As you look at the engine from the front, it's rotating clockwise. So the down windage side would be
The driver's side.
on the right as you're facing the front of the engine, and the up windage would be on the left as you're facing the front of the engine. On the up windage, so the oil and air wants to leave the rotating crank assembly. We have a curving bottom in the upper oil pan that takes it and it curves about a 3/4 inch radius. Then you have a flat section at about a 5-degree down angle. Then it flows into a slot on the up windage side that encourages it to go into the pan, into the sump. And then there's air bleeds on the other side. So you have it rotating clockwise, the air and oil rotating clockwise above the tray and counterclockwise below the tray. And hopefully the oil drops out of the air in the sump, and only air comes back by breather slots on the other side of that tray. So far, our performance is equal to or better than the GM design. But the GM design has to clear the front part of that steel oil pan is real narrow. I think it has to clear the front differential on a 4x4. There's a bunch of chassis-related
constraints there.
Yeah, there's stuff going on that is compromising the performance capability of the bottom end oiling system. So we're doing a full-on competition setup. And yeah, go in a boat, go in a Chevelle, go in an early pickup. The depth of the front of the cast pan is high enough to clear front cross members and those earlier things.
Okay.
So, yeah, we're after it with a vengeance.
That's great.
That's
what I like to
essential.
hear.
Yeah.
I mean, the aftermarket needs, in my opinion, the build market and the build, engines for build, right? Like put an engine together, build it, crank, pistons, the whole 9 yards, tear your LML apart or tear your LBZ apart or whatever. It's a process. The truck's down for 3 or 4 months, whatever. I see this, the L5P looks like a really strong foundation to have a factory built engine, to know the quality is there, to know the assembly quality is there. to have it engineered and ready for a certain power level. The crate market engine, I feel, is primed. It's ready.
Yeah, we were starting to see more and more swaps these days, unique builds.
Yeah.
Guys are doing crazy stuff. Obviously, we've had guys like Nathan Mueller on who did the Duramax Camaro. We've had on Eric Swanson from Duraverb. It's starting to become something that's really desirable for the end users. Guys are really starting to look, what can I do? And like you said, it's like if you think a regular motor build project is a long project, like just wait until you try to do a swap into something else.
Yeah, I mean, if you think your LS1 build or your small block Chevy build took forever, I mean, wait till you build your Duramax. You know what I mean? I feel like everyone we deal with, it's the machine.
It's not a small block Chevy.
Right, exactly.
That's for sure.
Yeah. So
what's going on here currently? Diesel Power Magazine is using Banks power to showcase the L5P. In the May issue of Diesel Power will be a teardown. I think there's 65 photographs in that. It's online right now. If you go to Truck Trend magazine.com or whatever they call it, and go to Diesel Power, you will see the article on the teardowns.
We'll put a link to that in our show notes.
And we're going to follow that up with we're going to take the same engine, build it back stock.
Okay.
We're going to qualify the clearances. We're going to check the balance. Just make sure it's perfectly happy.
Yep.
We're going to fit a performance damper. I don't want to be screwing with anything, so we'll fit our probably one of our military prototype dampers. It'll probably be about 90 days before we have the commercial aftermarket damper for that engine. So, and we're going to find the limits. We're going to find the limits of the pistons. We're going to find the limits of the stock turbocharger. We're going to do all of it. I think the first limit we will find will be the stock turbocharger. We're going to run out of turbo before we run out of engine strength. These things got a lot more oil pump, a lot more water pump, and a lot more oil cooler than the older engines. So it'll handle more thermal load and not kill itself.
Yeah.
But we're going to find the limits. It'll all be in Diesel Power Magazine. They usually do the stuff online first, and then they do it in print. But online, you get way more photographs than you can in print.
Right.
They're going to have to kind of cut back the photos in print, I would imagine.
I want to turn you back just a little bit. We went all the way up the L5P on the air handling system, with the exception of the turbocharger, and you just kind of touched on it a little bit. And this is the first engine from the D-Max program that, in a long time, since the iHigh, that's broke from the tradition using Garrett variable vane technology, and we're on Borg-Warner stuff now.
We're on Borg-Warner. The Borg-Warner stuff has different variable geometry design. It can take, I think, maybe 100 to 150 Fahrenheit higher EGT sustained. It's, the L5P is a high EGR engine, as are most modern diesels.
Mm-hmm.
And what does that mean? Well, it means the compressor turbine match is optimized for that. So we're watching drive pressure, and we're watching boost air temperature as well as pressure. In other words, we're watching air density from the compressor. We will map the air density versus load that the compressor produces, and we'll map the drive pressure, and we'll be measuring the RPM of the turbo. And basically, I think we're going to run out of turbine before we run out of compressor, is what I'm saying.
Yeah, it's a pretty...
when the drive pressure starts going for the moon, you're out of turbine.
Right. Now, when you guys are doing this
especially
mapping...
if the boost isn't going up much. So the bottom line here, we'll find the limits of the turbocharger, and we'll publish all of that. All that stuff will be both on our Facebook page, which is Banks Power. All the stuff we do on this, I want to get it out there so guys are hot rodding these things and having fun with them. Then I want to sell them some pieces.
Right.
I want to sell them Banks Power stuff. But the bottom line is, why keep it secret? You know.
Yeah.
So the Facebook, Diesel Power Magazine, Truck Trend. There'll be some stuff over at Diesel Army online, and Diesel World. We're going to be doing stuff with Diesel World as well. So this is, you know, the next 3 years out here at Banks, we've won the damn military business. It's the biggest thing in my lifetime. But it's not near as fun as talking with you guys in Hot Rod.
That's what it's all about, man.
Banks 2.0 in full
Yeah.
force. I love it.
Yeah.
I love it. Gail, before we
Yeah.
wrap up here today, because we do respect your time and you have been just a wealth of knowledge for us, anybody else that you want to give a shout-out to or any final comments about the L5P that you can let our listeners in on?
Well, you mean in terms of GM or...
Just in general, any other information you want to share about the L5P for guys who are maybe thinking about upgrading from their LML or LBZ in the past?
There's never been a Duramax as rugged as this thing. You know, guys will talk about the tank hanging down underneath the truck as a big negative, you know, for the urea
Right.
injection, but stuff like that. But one of the coolest things the guys have done is their cold air hood. To me, and I put it's on my my personal Facebook page is Gale Banks Turbo. Gale Banks Turbo. And sometimes I put stuff up there that's not on the company site, Banks Power site. I went to an introduction that GM did out here some months ago on the L5P. They had 3 dynos set up in this old warehouse downtown L.A. and had all magazine people in there, and they had a chassis dyno shootout going on, all kinds of stuff. It was a fun evening. That's the first time I saw that cold air hood set up. They bring the air in on top of the hood. They have an air-water separator hanging under the hood on the driver's side of the hood, kind of a plenum. They have a duct that goes across the hood and into the intake air system on the left or passenger side, and pardon me, the right as you sit in the driver's seat side. And it's a pretty nice cold air system all around. You know, I'm a ram air nut. I've been doing it since the 50s. So it's a...
There's definitely some time spent on that.
I mean, Civics or Duramaxes, I love a hood scoop.
You would, Paul. You would.
Well, yeah. It looks pretty cool cosmetically. So the deal is, we're going to measure the density gain through that system as compared to an earlier style truck.
Okay.
And that we'll be putting all this stuff on Facebook. That's my main. Or the guys can come to bankspower.com and sign up for our Banks Insider feed.
There you go.
That Banks Insider is where everything will be. I mean, the stuff I put on Facebook will be reposted on Banks Insider. If you sign up for it, we will not try to sell you stuff.
Totally true. I signed up for it.
Just
It's good
information.
stuff.
Okay.
Yeah. Just like if you sign up for our
It's been kind of thin the past few months because we've been thumping on the L5P. but it's coming back with a vengeance. And also on Power Auto Media, my entire career is there right now. And it's been posted. They did an article, came out here and did an article on my career from 1956 forward.
No big deal.
And a lot of pictures. Lots of pictures. So that's on Gale Banks Turbo on Facebook in my feed.
Very cool.
So lots of stuff to see. And I think the next time we talk, we ought to talk about the results. So what we get off this L5P build.
I think we should probably do a video podcast next time, maybe from Gale Banks Dyno Cell. I don't know. I'm just thinking out loud.
Yeah. We can always
Are you guys going to go video? Are you going to do video?
I think we should come on site and do some video, Gail. I don't know.
Yeah, I think I can fit that in my schedule.
Hey, it's on. If you want to do it, come on.
All right.
Let's do it.
Love it. Well, Gail,
Rich is smiling over here.
Yeah, our producer Rich is smiling. I just immediately found availability in my schedule. That was amazing. Turns out, yeah, my social coordinator said it was okay already.
Great.
But yeah.
Well, let me lay it out for you. We could also go out to the NHRA museum. My whole career is in that museum
Check out
as
some
well.
cool stuff out there.
Hopefully there's something interesting there. And if you're into music, jazz, blues, or any of that, I have a Monday night jazz hang. I go over to Mount Washington to a buddy's house, and 9 people are playing jazz there every Monday night.
Oh my God.
That is part of the. Yes, that's definitely going to be part of it.
If you're at all into that kind of music, it is a life experience.
Sold.
So
Deal. I'm in.
If you're coming and you want to go to the jazz deal, then plan on
Monday.
being here Monday night.
All right.
We'll go.
All right.
Sold. Well,
you're on.
Well, now that we just booked that, I can wrap up the show. Again, Gail, thank you so much. Again, just as always, really amazing to have you on. We definitely appreciate you and your time.
Yeah, absolutely. It's been great content. I mean, to go through the whole top end of the L5P, I think we got a lot of wheels turning out there for gearheads, man. They're trying to figure out how they can get this motor in their next build, or what they can do to finance this next truck.
And we got a little Cummins in.
Yeah, a little bit for the inline guys.
Yeah.
Nothing wrong with that. Well,
you guys tuned the shit out of Cummins. I'm sorry. I swore, didn't I?
That's never a fucking problem.
Well, to everybody who listened this far in this podcast, thank you from Gale Banks.
Right on.
That's so awesome. This has been Paul Wilson.
I'm Nick Prignitz.
Thanks for listening.
Calibrated Power Solutions, the leading North American developer of clean diesel power and home of Duramaxtuner.com, is the proud sponsor of the Diesel Performance Podcast. Calibrated Power develops emissions-equipped tunes for a wide variety of diesel powertrains, including the Duramax, Cummins, Jeep, John Deere, and many more. For more information and the best customer service in the industry, check out calibratedpower.com or call 815-568-7920. That's 815-568-7920. To reach out to the Diesel Performance Podcast, send us a message through Facebook or email Paul at Duramaxtuner.com or Danny at Duramaxtuner.com.
So unofficially, Gale Banks says GM's got 480 potential on this motor?
Yeah, call it 500.
That's where I would round it. And hey, guys.
Yeah.